Okay, I think my microphone's working. Should be.
Yep, I can hear you.
Okay, cool, perfect.
It's a little quiet, but other than that, it seems fine.
Quiet. Let me see. Sometimes it gets on the laptop
Sounds
speaker.
perfectly fine to me. 1, 2, 3 for comparison.
Okay, how's that? Is that better?
Yeah,
Louder.
that's louder, yeah.
Yeah.
Okay. Okay, so just before this meeting, I finally got V7 of the base kind of TSM stuff going. I'm hoping that's the last version, but take a look. So I trimmed it down. I pulled out the unit tests. I pulled out a couple other things. So it's just the first 9 patches that is the first 9 patches as the core enabling, and that's it. And so on the staging branch, I also pushed out the address association patch from Elune, and then that one about the different stream IDs and whether and making sure that they're all unique at the beginning of time. I put that commit in the staging branch. It wasn't in the patches, but if you go to the staging branch, you'll see it there. The question I had about that one was, I think stream IDs are unique per port per port pair. Like right now, I have an allocator at the host bridge level that makes sure that you get one unique. Like the host bridge has 256 stream IDs that you can pick from. But I think you can have like a for one root port to one device, you could have 256 stream IDs, and from the same root port to a different device, you can have another 256 stream IDs. I think there's no limit on stream IDs as long as you have a set of 256 per pair.
That has been my understanding so far.
Okay. So yeah, I might need to rework that. I might need to rework that patch, but right now it has like a single stream ID allocator per host bridge, which is probably not right. We could do an allocator per device.
Wait. So you have one per root port or per PHB, like host bus?
I had it for one host bridge, but I think you could actually have an allocator per device because it's per pair.
No, it may not be always like that, because the CID specification allows the 256 stream IDs per root port per port pair, but it is possible that the platform would impose some restrictions on the stream ID allocation.
Is that a TDX limitation? And do you think it's per stream? Like what I'm hoping or what I'm guessing is that maybe an allocator per host bridge is okay for now.
Yes. I think the allocation from the host bridge ID pool is from the TDX requirement. It original from TDX requirement, is it? So we have the host bridge ID pool.
Well, we have the host bridge. We have the host bridge stream pool, which is separate. And I keep on making a mistake, and Alexi pointed out to me, he's like, oh, that your fix is allocating stream indexes, not stream IDs. Like so we could have like on TDX might only have four streams that can be active on the host bridge at one time, but each one of those streams could be 0 to 255 for the first one, 0 to 255 for the second one. It doesn't, the stream ID shouldn't matter. Even if you only have 4 that can be active at one time.
Maybe, okay, maybe yes. Maybe I need to double check that if it is a stream index matters or stream ID matters.
Yeah.
Okay.
Yeah. Well, but take a look at the patch. If it works for you, Alexei, let me know. But it does make sure that within a given host bridge, a stream ID is not reused. But that might be that. But I put a note in there that this might be wrong, and we might need to revisit that.
Okay.
Or we could just write FF in every stream as an ID if stream is not used. And if it's used, we need a locator. Yes.
Well, okay. So what I did was I have an allocator, and I reserve F. But in the allocator, I reserve FF. But it can still be the case that something tries to use it. Like I noticed, like right now we're just kind of hoping that nobody exhausts it on TDX, because on TDX the TDX module picks the stream ID. We just inject it, and so I picked 255 as the reserved one because that'll take a long time because the TDX implementation starts allocating a 0, but we might need a interface to say, hey, TDX module, you can't use FF. That's only for Linux to use as a reserved one. But if it's FF and per device, then we don't need to worry about this collision.
All right, I'll pull and see how it works.
Okay. Hey, I see Peter joined. Has it? Hey, Peter. Welcome.
Hi, thanks. Just trying to listen in and catch up.
Okay.
Appreciate it.
No worries. I mean, we're wondering where you were because the past few times we've been giving you a lot of work to do, but you haven't done it. So glad you're here.
That's true.
Okay, no, good. Yeah. Feel free to listen in as we're really debating a lot of these harder platform specific details. So it may help you go to bed tonight if it gets too boring. But I cut somebody off. Was somebody asking a question? Was that still Yilun or Lexi?
No, if we finished with that, then generic question, I say rework my patches, moved some stuff out of the initial 40 patch set. So now I have, say, 15 patches on top of yours, which includes small fixes for your patches and my patches. I am hoping some of my fixes of your stuff will go away now.
Yeah.
And then do we start posting? And we start posting both host and guest support, so people would see how it's gonna work, or just host and IDE connect.
So I think I don't want to restrict anything that you want to do on your tree. So if you want to rebase the whole thing and do and post end to end thing on your tree, that's fine. The things I want to do on the staging tree is get your 15 or whatever patches you need to also support this first phase. So actually, let me show this document, and maybe that this can help answer the question. Where did I put this? Hold on a second.
So prepare branch, push to GitHub, and then you pull from it and merge.
I'll merge it into staging. We'll say, and then we'll say, look, we have our first vendor contributor to the staging tree, and whether those commits exactly match the ones you have in your tree doesn't really matter to me. It's up to you. And then what I'm planning to keep stable is like those first 9 patches, put them in the next branch, keep those stable, and then you should be able to send whatever you want to Boris for merging, for S&P merging. If that's that's the path you want to take. I mean, if you want to go through Boris, that's fine. If you want me to do a pull request, like and if I can get a couple, if I can get the Intel TDX and maybe Anish as well too.
I mean, if all of this is aiming Linux next, then we don't need to involve Boris right now.
I mean, yeah, for staging, it doesn't need to involve Boris at all. But for Linux Next,
we do.
Well, it depends. If you, yeah, like I don't want to step on x86 trees turf. If they want to take it, I'll let them. If they want to hack it, I'll let them. But right now, you tell me.
Okay, I'll catch Boris tonight and just ask.
Okay.
Where is Peter located? I'm curious. What continent?
Are you in the Bay Area, Peter?
No, I'm in Colorado.
You're in Colorado, okay.
Yeah.
America.
Yeah.
Okay, I'm trying
What
to
next?
show this.
Right. Do you have any instructions written somewhere on some web page about echo TSM0 to connect, to get it connected, and or it's all in documentation folder in Linux and that's it?
Do I have a web page for it? Hold on, let me see.
No, it's the valid answer. It's just people are trying it.
Yeah, so I have
how to use it.
Yeah, I'll show you a couple things. What I have. So here's the staging branch. Why is this not going? Oh, this way. Okay. So I have this script, which is using that sample driver and just echoing a whole bunch of things into different flows to connect, disconnect, bind, unbind, random things. But this really is testing object lifetime. But this is not a document. This is like a usage document that says, okay, if you want to connect, here's what you do. So, yeah, I think.
I mean, at some point, your integration testers should have asked you, how do you build? How you compile QEMU? I don't know. How do you connect? How you bind? How you unbind? You should have received a bunch of questions like this. And I have some Word document, which I sent link to these people, and then go away and then come back with more detailed questions. And now I'm asked to publish it somewhere, and I don't really want to, because it's basically repeating what you do in this script.
but I think what this script does, we should probably put it into the document. And the document I'm talking about is this one, PCI TSM.c, or TSM.rsc. I think we can throw in some usage stuff in there. If that helps, I can do that if that helps.
All right. I'll see what I can do.
Okay, but I mean, if you already have something, let me. I'll put it in here. If not, I can write something up and just convert my test script.
I'll just write a patch and put it in the tree, which is going to be merged to your staging tree.
Yeah.
And then you feel free to play with it.
Reorder and plug it in. Okay. The other thing I'm doing, so the question, so you're getting those questions. The question I'm getting is from people saying, "What is the staging tree? What is in it? How do I know at any point in time what is it good for?" So I put this thing I'm calling a maturity map in this document. This commit I'm going to rebase as we pull stuff in, but this is kind of like my dump of everything that I know about and whether it's in or out of the staging tree. And it gets a score from 0 to 3. 3 is the best, meaning we're done, and 0 meaning Zero means we haven't started. We either haven't started working on it, or the patches that are there for it are in the AMD tree or in the ARM tree. They're not in staging. So it's zero just means not in this tree. And it's broken. I collected the topics into like 4 different phases. I'm hoping that we can do like a phase 1 for 619. So this would just be the core, enough to do IDE. That's it, or an SPDM session establishment. The number of architectures in currently the staging branch that can do that is 0, but we know all 3 of us can do it. But yeah, we got to get them integrated. And yeah, so then I'll update that as we see things go in here.
So this maturity map is new, right?
This maturity map is brand new as of like an hour ago. Yeah.
Okay, good.
and yeah, if because I get program managers, I get people from the other companies asking like, what is this? And like, go here. Everybody has the same question. Go here. And then the phase 2 thing is all of our all that guest side stuff, lock accept stuff. Phase 3 is the big fight on all the VFIO, IOMMUFD, all that bind flow, that fight, and then attestation. So
that's separating 2 and 3 is a bit tricky. If you accept, then things will just stop working and start crashing. Hardly a useful milestone for outside observer. The user.
So the reason I have it staged this way, and this is because this is in conversations with different people that are trying to deploy this stuff or track it, is that if we get this stuff finalized, even if the host side is not there working or finalized, because this is the guest side, then this can start going into the Ubuntus and the Fedoras of the world, and people can start building VM images. These things that are in the host side need more time to develop, but like as far as I know, some of these CSPs are okay to kind of ship some out of tree stuff, early stuff on the host side, but they can't do that on the guest side because guests get to bring their own kernels. So that's why I have this separated. Is like, yeah, Linux may not be able to actually do any of this stuff, but you could let's say we get this into this phase 2 stuff into 620, and phase 3 stuff is in 621 or whatever, 7.0, whatever kernel that is. You could run a 620 kernel on top of a 7.0 host and not need a new kernel kind of thing. So that's why I have it ordered this way, because getting this done first means we can start that whole ecosystem going sooner.
That sounds great, Dan. That makes sense to me. Is the phase 4 is that just your personal ordering, or this is only blocked on phase 2? So
correct.
3 and 4 could run in parallel.
3 and 4 can in parallel. 4 can run right now. Like, yeah, we and I've kind of had the last few meetings has kind of had an open invitation. Like, anybody wants to work on device attestation and move that along is welcome to, because yeah, we're going to be busy on these other 3 phases for a while. Lucas Wunner had been working on the host side. He's getting back to it on the kind of native authentication side. The only thing is that stuff doesn't comprehend interface reports. It's not clear that it's going to be a slam dunk fit for what we need, and whether we might end up with separate interfaces for TSM or not. But yeah, I am openly requesting help for people that want to drive this piece of it, and it really can be independent of anything else in terms of schedule.
So
sure. What do you?
Sorry. I think we are going to need to have 2 separate solutions, one for CMA and one for TDISP, because we have customers that are interested in one but not the other.
Okay. Yeah.
Yeah.
And it doesn't seem like CMA is close enough to what TDISP, like TDISP has so much more stuff it needs that we could get all the way to a finalized CMA implementation and still have a lot of work to do. So
Yeah, because you don't need IDE or anything like that for CMA. You literally just need the SPDM session.
you need a session, you need a transcript, yeah, and I mean
Yeah,
build it. So basically,
Yeah.
TSM is almost a superset of what CMA needs.
yeah, essentially, yeah. Because TDISP also has the well, to be honest, TDISP is separate from SPDM, right? It just uses SPDM for secure session establishment.
Right. Yeah.
Like you said, I guess that's exactly what you just said. It's a superset of SPDM, essentially, or CMA rather.
So yeah. So I think we'll talk. We'll also talk about this in plumber. Like I also this is basically my plumber's talk. I think in advance, but uh, I I do need to get more details here on the top. Like I think I've been so focused on phase one. I know Alexi and Yulun, you guys have been in a niche. I've been looking at the IOMMUFD pieces. I'm still kind of catching up there on what still needs to be done. Aren't we still kind of dependent on Leon to win this fight about with DMA buff? Like there's a few ongoing community discussions that I think are impacting phase three, but I'm expecting phase three takes the bulk of the time in this whole thing. Like 1 and 2 and 4 are pretty straightforward.
Makes sense. What Dan? What do you need help on with phase four? What could we get started on that would be useful?
So okay, so when Lucas went to Plumbers to show off his SysFS interface for dumping out information, he started doing a demo and said, "Oh, like if you need an ONS, if you need these other parameters, you have to do this kind of complicated SysFS dance." And people say, "Whoa! If you need to like add parameters and do things, you should move over to Netlink." Um, at the same time, like if you look at, I haven't looked deeply, but I understand from Alexi from your implementation, you're like it's just binary attributes. We just dump these things, um, and that should be sufficient. So the help I think I need is basically taking that is getting those people that gave Lucas that feedback to also look at the Lexi thing and be like, hey, can we just do simple SysFS, or do we actually need Netlink for TDISP and to do it with nonsense? So it's really just somebody to put out RFCs, get community engaged, get community consensus alignment on what these things look like, and just implement it.
Okay, yeah, easy. I think that's taking a look at Alexi. It sounds like you have some POC patches. I'll start there, take a look, and then try to find the plumber's artifacts from pointing to Netlink. Make sense?
Yeah. I mean, that'd be like, yeah, it's really just been missing somebody that has been with.
See what Lucas does is, like on bare metal, he creates this PDM session and say reads all measurements of the device. So, and he saves this transcript and exposes it via SysFS to the user space. And because he is doing all these commands from host kernel, right? He has all of them and he can organize things in order. In my case, I rely on the PSP, which is this little small firmware running on the core, next to the core. And that thing issues all these SPDM commands. And that thing collects them all in one buffer and returns me as a whole blob called transcript. And since hostOS has nothing to do with it, that's no use for it. It's for the guest. I just take this blob, expose it by SysFS as a binary blob. Then I have Python script to parse it, just to see if it makes sense. But what I do essentially in QEMU, when guest requests this measurements report, I just copy it to guest memory, and the guest kernel exposes it to guest user space, again, as a binary blob. And then that guest user space attestation tool, which can verify the device and attest and enable, that thing will have to parse. And the same Python script basically goes through this transcript and checks everything and then decides what to do. Same with certificates blob, which I don't parse anywhere between PSP and guest user space. So it's quite different what Lucas does.
Do you have a flow for the guest to retrieve the transcript with a nonce that the guest provides, and like do it through a guest request?
Yep.
Okay.
I have special page like data buffer, and if it's not 0, then it's just 32 bytes is used as a nonce. And I updated my GHCB spec to say that.
And you learned in the TDX preview patches, you have something similar? You have a guest request or not yet?
Yeah, you mean the
Guest request
guest request
to supply a nonce to retrieve the interface report and all these things with
Yes, I think it's somewhat similar that when the host side TSM driver gets the blob from the guest, it will query into the nonce field that is defined in the GHCS spec. And when the nonce are not 0, then we will use this nonce.
Okay.
Yeah.
Because
so my point was that if we want to unify with Lucas's effort, and that we need to pick one CSFS interface, and whatever Lucas has now is just useless work for us, because we don't need to parse it and expose the way he does, because
right.
it's extra work.
I think that my idea is that on host side we may not have to align with Lucas's CSFS method for the for the attestation result. For guest side, we need to align with Lucas.
His stuff doesn't run on the guest side.
Yeah, but we are talking about the guest requesting interface on host side, is it?
I guess
no, the question was how Peter can help with device attestation thing. Phase 4 on the screen.
Yeah,
yeah, that makes sense. Alexia, are you measuring in that transcript into the VM root of trust or the guest root of trust at all?
Measuring transcript. I received transcript. I do nothing with it, honestly.
Okay, all right. that was helpful. I think I have a good understanding of what to read. Thank you.
Yeah, I think I mean this is the open. It was kind of an open question, or that's kind of been floating around. Is what is the attestation model for devices? And my assumption, and I think everywhere we've been going, is that devices are independently attested, and something else has to do the work to say, okay, here's a device I measured. Now let me extend some VM launch attestation based measurement to say, okay, now here's the combined thing.
That makes sense to me. Yeah, before you allow DMA globally, you'd want to update your attestation with that, right?
Yeah. So yeah, like hey, I reached a state where I've added all the devices I expect to be there, and I've extended them. Like, verify, please double check this is the state you expected, kind of thing. Yeah.
Makes sense. And that's user space doing that in your mind right now, Dan?
That's users. Yeah. That once you get to the lock state, that you can retrieve all the measurements you want, and you can actually also transition the device to the accept state from user space whenever you want to. You don't actually have to do the attestation, but if you do,
yes, optional, but
if you do, yeah, then user space is having to combine the that TSM report interface with whatever gets out of this PCI interface report interface. So combining TSM reports and interface reports is an exercise for the reader kind of thing.
Well, but there's already people working on that. So the Linaro guy has a new device attestation EAT, which is used with which is meant to be used for getting the device results, and then the ITF guys working through the Verizon project are you working on a daemon called RATSD, which has all these plugins, which you'll be able to say, give me a TDX TD quote and give me all the device attestation tokens that I need, and then it uses COSI to kind of wrap it up and sign a concise message wrapper for the whole thing. So there's user space people working on that part of the problem. The problem we have right now is that there's no way for them to obtain device information. They could write a plugin tomorrow to start pulling device reports if we had a kernel interface to do it, but they don't.
So that this Matthew Perwar guy came to the morning version of this meeting and was presenting the EAT token, but he's saying that the EAT token doesn't comprehend interface reports. But you're saying that RATSD doesn't care if it's an EAT token report or not. They just need give us the blob and we'll do the rest, kind of thing.
Yeah, so the RATSD was in a different presentation. I forget which meeting it was, about a month back. And they said right now they have the agent that's capable of pulling TDX reports, signing them with a platform key, and then sending it off to a verifier, or at least providing it to be sent off to a verifier. So their to-do included things such as, device attestation plugin support, where they'd write a plugin using, whatever the device interface is. Because right now, in theory, they could write an SPDM plugin for RADSD using NVIDIA's proprietary SPDM interface, right?
Okay.
That's available on the B200 cards, I think. So, but there's no generic kernel interface for them to use, right?
But they only really care about a transport to get blobs. They don't actually like if that so we have the TSM report interface, which is just a blob transport, and it spits out AMD blobs and Intel blobs, and there's no format to them. It sounds like you're saying that if we had this generic transport, and sometimes it spits out AMD interface for AMD formatted interface report blobs, and other times it spit out whatever Intel TDX does, that wouldn't be a problem for them. They just write
So
plugins.
So my understanding of the architecture was the plugin's responsibility is to use the interface to grab whatever attestation information is necessary for that entity, whether it be a TD or a TDI or whatever it is, and then it does some conversion to concise evidence for it. And the nice part about it is that if you want to have a nonce for your measurements, it also will propagate that nonce to all the various gathering plugins that are needed so that you can be sure the same nonce was used, say, to grab the TD quote and the whatever 2 or 3 device attestation quotes that you need to represent the system. Then it gathers these up in concise evidence format. It uses concise CMW concise measurement concise, I think it's concise measurement wrapper. And then that's a different standard, which tells you how do you take all these different bits of concise evidence you've gathered from all these entities that don't relate to each other than the fact that they're all on the same platform. And then COSI is how you go about signing that result of everything after it's done.
I mean, yeah, that sounds like that sounds perfect. So, because I think the interfaces that we have, it will tell you like when you lock the device, you can work your way back to ask like who locked this device. Was it locked by the Intel TSM or the AMD TSM or and so you could use that to key off you could have an AMD plugin, Intel plugin, and ARM plugin, and you wouldn't and they could all use but still grab the same blobs. Yeah, so I'm feeling more and more like Peter, if Yeah, if the Lexi approach looks good, I think it works for it works for TDX, and then we just need to kind of get like the James Bottomleys and the other similar people that gave Lucas that feedback to be like, hey, this is what we're gonna do on the TSM side, please engage and either
Yeah,
tear
no,
it up or
that
not.
makes a lot of sense. David, do you have a link to that? I found the RATSD, but I don't see any device device mentioned in that
Yeah,
documentation.
so that was in a presentation. I feel like it was the attestation working group. Let me look through their presentation slides and see if I can get you
Cool. Well, I'll poke around
the
there too.
slides
Thank
for
you.
that because they definitely don't support device attestation right now because there's no kernel interface for them to use to get it. So that's their on their list of future things that they're going to implement once the interfaces pop up, which is why I said if we can get the interface working, and in theory, it'd be ideal if we can get the interface working in a way such that it's, if it's, CMA, it's not plumbed to go through the TSM, but if it's, at TDISP, it's plumbed to go through the TSM. Um, that would be ideal because then we'd be able to support both with a common interface, which would make things easier.
Yeah.
Okay, and I found it. Thank you.
And and right now the only place we collide with kind of Lucas's work is on the authenticated attribute. Like we have a TSM subdirectory, so if we wanted to have ABI under there, we can. And if Lucas defines something common, we could figure out how to move to it. But it would be they can develop independently, and we can keep the stuff. We can keep a TSM namespace for a lot of this stuff. I did want to highlight that one. So it's not on the first 9 patches because I didn't want to touch those anymore, and they had to. So those are the exact same ones. Nothing changed, but I did add some stuff to the follow-on patches. So in the follow-on patches, we have the address association thing that Elune put together. I have your workaround, Alexi, for the stream ID. I still kind of want to figure out if, well, I mean, I get you say that device is going to go to production, so yeah, well, let's just assume that's the case, and it the workaround makes sense that like some devices would prefer those things separate. So I think I think we don't need to make it a quirk; it can just be a core feature. But yeah, this one I added DSM and bound indications to sysfs because because one of the bugs that Yulun found was like, oh, like because you don't test the non-physical function 0 device as the thing being bound, it misses some bugs. So that was the main thing that took me some time to get this patch out, was testing that case. So now the sample code adds a multifunction device where function 0 is the DSM and function 1 is the TDI, and that will
So DSM is a string or symlink?
DSM is a string because sysfs doesn't let, like, ideally I would have the symlink just pop in, pop out whenever you connect, disconnect, but you can't do visibility on symlink. So it's a string, and it's just the name of the PCI device that is the DSM. And so on physical function 0, that'll be yourself. On virtual functions or non-function 0, it'll point back to function 0. Just in name. But I mean, I mainly added that so I could write tests and be like, hey, because when you connect, you have a whole bunch of PCI devices that actually are connected, but you have no idea that they are. Like there's no, like, I noticed that all our virtual functions, there was no TSM attribute for them. You don't know who the DSM is. I think it also gets extra complicated when we have this concept of upstream switch ports being the DSM. So the downstream endpoints need to know who their DSM is. So that's why I added that. But then the other thing was for if you bind a device, the device is going to start acting strangely in some cases, like in the sense that you probably you probably shouldn't touch the busmaster enable or memory space enable from the host side, and these things need to be managed, and it's consuming resources. So this bound attribute basically tells you, yep, this host side function is consuming TSM resources because it's bound up, and so this is also the name of the TSM device that it's bound to. And yeah, so just a couple new SysFS attributes, but these are read only. You can't bind from SysFS. You still have to bind through VFIO, but the state is visible in SysFS.
Good, makes sense. I was missing the DSM node in my smoke test script to read certificates, which are only should be present on PF0, and I have devices with 4 physical functions and many virtual functions.
Maybe, but yeah, and need some help to keep them all straight, kind of thing. Yeah. This will come out in V2, like V2 of the guest side stuff. Yeah, so we have don't have to get into it here, but this is the proposal about how does the TSM driver communicate to like IR remap what should be encrypted and what's not. But yeah, we can save that for the list, because these patches are still kind of IRC quality.
Oh, I couldn't see that, but I mean, did you say, Dan, you're working on some patches going to, or some pages going to device can be encrypted and some decrypted?
Yeah, like the primary case is that at least I think all of the current implementations, they don't support the MSI MSI configuration space or setup space to be encrypted, and so you'll have encrypted MMIO for everything else, but the MSI page will be shared or decrypted. And so
well, we could do that probably, but we need to make sure that VFIU is not touching MSIX bar when guest has accepted TDI. So at a certain point, you cannot write to MSIX bar as unencrypted. So
sorry, which branch was that patch in? What patch was that? I wanted to ask, actually, we have a similar need to want to actually have some portions of the device's memory be public or plain text, and be able to control that from within the guest. So it seems interesting.
So right,
this is not controlled by the guest. It is
no, well, it kind of is, because initially device comes with the interface report which says this bar is encrypted, this part of this bar is encrypted, and this is not encrypted. And then guest can actually request change of attributes.
But the guest need to conform to this report. You cannot say that the report says it is encrypted, but you map it as shared.
Guest can request change of attributes from in the device. There is a command in tdisp, and then it can map it as it wants if device supports it. So
yes,
device
exactly.
has to support it.
But you have to ask. You say, I got the report. I don't like this report. I changed the report, and then you ask for the report again, and hope that it has allowed you to mark something.
Then you need to send the TDSP messages to change the memory attribute, and if a device agrees, I think maybe you need to get a new report, and then finally you still need to conform to this new report.
Right.
Yeah.
Well, you don't have. I guess you don't have to conform to it if you don't care about security. I mean, like you could. The report attests to you that this is the configuration. Oh, but the guest could still map it incorrectly, right?
Yeah, yes,
Yeah.
but if you map incorrectly and then you access the MML, let's say, not expected by the device, then the TDSP state would break.
Go to error state, right? That's right.
Yeah.
That's right. Yeah. The device is saying my job in the run state is to enforce that everything in my report that said it was supposed to be t equals 1, it had better have t equals 1 when it gets accessed. That makes sense. But 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 Peter, to your question, like this IRE patch is basically a scheme to say um, how do we communicate from different parts of the kernel, like so the TSM PCI layer says, hey, I know that these bars that I mapped that I mapped at the beginning of time, some of them need to be marked encrypted, some of them don't, and the proposal here is to do that markup in the resource tree.
Right.
Okay, I
So
found
the
it.
point
Yeah,
is the driver is not updated. Driver is still doing PCI IO map and
Yeah, driver still does PCI IO map, and something else has arranged for that communication to happen.
Can you scroll this down a bit?
Yeah.
Because I did make comment on this one, and it didn't work for me exactly like this.
It didn't work for me either, and I fixed. So this one I fixed.
Ah, okay. Yeah.
Oh, you
to
have
do this
fixed it.
just
I fixed
encrypted.
it. Yeah. Yeah. Before I try to do it all in one walk, and you can't do that. It'll skip things. So now there's a separate walk for checking if it's encrypted or not.
Right. So this patch of mine will go now.
Okay.
Good.
But yeah. So I mean that's the state, I think. But yeah. If we can poke along that kind of phase 4 stuff, that and meet after meet up afterwards, that'd be perfect. So Alexi, I think you're going to be at Plumbers. Peter, are you going to be at Plumbers?
no.
I'm not.
Okay.
I thought I will, but they have strange funding policy now.
Okay.
No one really understands it, and this year it's worse than last year.
Don't you just have to say like? I mean, even your email starts with AI, so that you should you should automatically get funded.
Yeah.
Okay.
I thought.
Well, yeah. Hopefully see you. If not, then we'll keep having these meetings and keep talking.
Because still this attestation stuff, if it's transcript, it's described in SPDM spec, so it's very standard. Everyone will do it the same way. And if it's a blob which you provide a guest user space, then there is no difference if it's from AMD, Intel, ARM, right? So it's the same standard mechanism. So if you go for this concise evidence, there is not much to convert, really. It's same script.
There is Matthew's device attestation EAT, which is kind of like, so the TCG also has a document called concise evidence bindings for SPDM, and they both kind of use an indirect measurement type where you're essentially just repackaging whatever you got wholesale from the SPDM message. You package this index, its type, and the data, whatever it is, whether it's a hash or a binary stream of data. I guess technically certain message blocks have other structured formats, like SVNs are structured to 8 bytes and stuff like that. But you would just package all that up from standard SPDM measurements.
So it's converting transcript into array of measurements, basically.
So the transcript's purpose, the transcript's only purpose is for you to be able to validate the signature when you request a signed set of messages, right? The measurements themselves come back in the request, as a series of measurement blocks, where each measurement block is defined as the type and a couple other things, the index, the type, and a couple other things that are in there.
Correct. And
Yeah.
who wants that signature? It's like the tool in the guest user space, which
Most
will
likely,
check signature before going to remote attestation server, or it's
Yeah.
remote attestation server which wants to check it.
Yeah,
I'm
this
not
is where
sure
things get
about
really
that.
complex because I've mentioned it before. There's really two different relying parties here for a device attestation, right? Because there's the guest itself, whose job is to decide whether or not this TDI is acceptable to merge into its trusted computing base, right? To bring into its security domain. So that, in theory, never even has to leave the guest. That could all be done from the guest. You could package a RIM in the guest for the driver that you have packaged in that TVM and ensure that a local verifier is getting the correct measurements back and verifying that result and giving you an EAR for that you could evaluate. Now, after you've gotten to the state where you trust the TD's been loaded properly because you can verify the host. You trust that each of the devices has been added into accessible to add into the TCB. Now you have the person who's actually going to give you data and models, right? So that's a completely separate relying party that you could potentially be actually it's multiple relying parties, right? Because you may be someone who wants to run a model on a system somewhere, but you may be getting data from, say, let's say you're doing a medical model and you want to get that data from a series of hospitals, and those hospitals need to be assured that the platform that you're handing them is going to properly protect that data, right? So you have this situation where you potentially have multiple relying parties for multiple purposes, and that's all after you've decided to actually set up the system to a point where it's usable, where you have your devices accepted and everything. So attestation is really hard, which is why I was hoping initially we could go for the low-hanging fruit of just making sure we get a good interface to be able to get those device attestation reports back to user space and let user space deal with all the complexity of orchestration of multiple hosts and dealing with multiple relying parties and sending secrets because if you really want to get into it, then there's potentially packaging all this up into certificates that are used in remote attested TLS to talk to a relying party, and it just keeps cascading further and further. If you want to take on anything other than here's some results back, now do with them what you will.
Wow, I see.
Yeah.
Never heard of hospitals. Never thought of hospitals in this picture.
Yeah. Because you could potentially think of it like you have, say, a cancer detecting model, whether it be from radiology images or some data or something like that. And that model would probably be, worth a fortune to whoever properly trained it, or they're trying to train it. And then you want to make sure that each of the people handling sensitive medical data, whether it be in the US or in the EU or whatever, can trust the environment that's going to be using that medical data. So
Makes sense. You mean there's actually real use cases for this stuff? That's all.
well, so
Well,
I'm not saying that we've had someone come to us with this use case. I'm saying I've looked at multiple use cases across multiple industries, and seems like a completely viable use case.
Yeah.
And I think actually we published so there's the Confidential Compute Playground that Intel has published, which has just demos that support TDX and in theory TDX Connect, but I don't know if those are how well those are supported. But they have things like federated learning, and that's a classic federated learning case, right? It's just a federated learning on medical data, use case.
That makes sense.
Yeah. Oh, there's tons of use cases for this. We just need to get the technology in the place where people can start using it. So
Cool. Okay. Oh, I want you and I are chatting about this, and I remember you had a device. This device you have, Alexei, that needs the default stream set. Does that device have address association registers too? Because I'm wondering if we should always. So you and I are debating, like, should we always set the default stream? If like, is there a heuristic we can use to define when to use that? Or you just have to know.
Yeah. I see my test device has the address association registers, but they,
Oh, okay.
yeah.
That doesn't help.
Mine does too, but it requires default stream. I'm not sure why.
Okay.
Maybe the new revision of that device doesn't.
Yeah, me
So we
neither.
tried it.
Yeah, I mean, I just see the default stream is disabled and it breaks.
Yeah,
I mean, if I don't set default and I set address range as like 0 to the maximum, it's still not working.
Okay.
Okay.
While it should have picked the stream, right, and work.
Yeah.
But that device, definitely development device, but now it's converted to some production device for some cloud provider.
And
maybe they fixed
the
it
problems-
there.
Maybe. Well, I guess. I mean, I guess we'll keep an eye on it. Like, if every single device ever produced requires it, then we should just set the default in Linux and not. Because right now, each TSM driver is having to set that as manually.
So
Which
what
is okay for
exactly
now.
is the requirement?
Well, it's not a requirement, but like when you're setting up the stream, there's a bit that says set this bit called the default stream bit, which means like any. Like, it's basically it's supposed to be like what to do with a packet, or an upstream memory, a TLP or packet that doesn't match anything. Should it go in the IDE stream or should it go not? And default stream basically says, when in doubt, always put it on the IDE stream. And these test devices that we're looking at, do not work at all unless you set the default stream. And we haven't been able to get any other IDE stuff out of them without setting that bit.
Okay.
But I took it
Even
out
though we only
because
have one stream and we enable everything on that stream,
yeah,
still doesn't work without default bit.
the whole bit, which is silly or weird. But I took it out because there's like it does limit you. Like, I think I had to go look at the person from NVIDIA who said, "Oh, like if we set this everywhere, it's going to be a problem." I'm gonna go back and figure out what that was. So maybe sophisticated devices don't want that set because they tightly want to control what goes. They know what's supposed to go on ID, what's not, and these kind of early devices were maybe a little bit lazier and just like, oh yeah, set that bit. That's
Now, when this thing becomes popular, we will just start creating quirks.
Yeah.
PCI quirks.
Yeah, there will be quirks, and so that will happen. That can also be in the core. Yeah.
I have one already. It's for TIO devices. There is a place when we cannot update 64-bit bar atomically, so we disable MUC, do the update, and then enable. And then there is this flag in PCI device. It says MMIO always on, something like this. So my quirk sets that flag to true for every TIO device. And it's my tree. I'll send it probably to staging tree. So there is a quirk already.
First one. Okay. Any other questions at the top of the hour?
No, but time for the kids, right?
Yeah. Time for us US people to go to bed and put the kids to bed, and yeah, and for you people on the other side of the world to finish off your day. Cool.
From noon to 1 p.m. I went to the ring. So.
Believe
it or not, we have Ice Hockey Association in Australia. And Australian like analog of Stanley Cup is played since 1920, 28. So it's one of the longest, actually, competitions in ice hockey in the world. Australians play ice hockey for longer than Russians.
Hey. That's pretty cool.
Yeah.
Yeah, I got the. I don't remember. It was a few months back, but I got to meet a lot of your old Power IBM folks that went to Tens Torrent, and I think I was at a gathering here, and they're like, "Oh, you know Alexi?" Like, yeah, I know Alexi. Yeah, and
Oh yeah.
I think they sent you a picture, but okay, yeah, we'll see you all at the next one. Thanks for this, and have a good rest of your day.
You too.
Yep,
Thanks.
bye.
Cheers. Bye.
Bye.